Okay, welcome everybody. I say this because, this will be replayed, I hope. And it's the first video of its kind from me where we talk about preparation for A-level mathematics from GCSE. So a little bit about my background in this. So I was head of Key Stage 5, head of A-level mathematics for about 6 years, and over that time, we developed a fantastic way of testing whether we are ready for the study or not, whether there are any gaps in the knowledge. Over the years, we see a lot of people struggle, and it would sometimes be quite late when we would realize that there were some key things that were missing. Traditionally, the diagnostic tests for A-level can be very full. There's a lot of different things in them. And we realized a lot of it was pointless. First of all, what is the definition of a diagnostic test? A diagnostic test is one where you are testing to find out whether you're at the right level for a course. And if you are being tested on some of the stuff that's about to happen, it doesn't make very much sense for you to be joining that course. Slightly different with A-level because everyone's forced to do education, at a certain level. But actually, it's a test to find out if you're good enough. So if you've got some of the content from the coming year and you know it, maybe you're overqualified. Is a good, indication that maybe that's not the right thing to be on the diagnostic. Today, we're going to look at some of those core skills, the skills that we're not about to teach you, but the stuff that you really need to be solid on. And over my 14 years of teaching this, these are the fundamental questions, the most important 5 types of question that you need to be sorted on. We're about to do this in timed conditions. So when you get yourself a paper, bit of paper, a pen, and get ready. You can't have a calculator for this, he says, hesitating. No, you can't. You can't have a calculator for this. This is these are skills where you get 1 mark for each of the answers, because when you get at A-level, especially when you get marks, you may get method marks, and then you may get answer marks. The method marks are there to support multiple bits of information that we're trying to test you on. And it's okay if you don't get it all right, as long as you were on your way to doing it. You get method. Any question that has just 1 mark, we call it given knowledge, right? You have to know it. You either know it or you don't. So you get 1 mark. And that's a lot like these questions here. I call these questions the grey questions. This is why we have the grey background today. They're called the grey questions. I don't know why. Let me think why. I have no idea why. Traditions for me, every year we would add a new grey item to the front cover of the test. It was fun. I think you can think of a few grey things. Concrete. The last thing ever added was an elephant. And yes, we did have cloudy storms. If you do hear something in the background, that's my dishwasher. Lovely thing, gargling away. It's very rude, actually, if it's a person. Very rude. Okay, let's get started shortly. I'm aware that there's 2 people here, and I'm hopefully, if they are actually here, they can say hi. I've got some concurrent viewers. If not, you're one of the people watching this on catch up. So you have the privilege of fast forwarding. But without further ado, we shall start. Now here's the rules. This is what's going to happen. I'm going to present to you in groups of 3. There are 15 questions and 5 sections, and each section has 3 variations. This is the result of many years of research, and they really are the core things to get sorted. If you are really good at these, have to get 100%. have to get more. You can't lie to yourself. But if you are really good at these and you don't do well at A-level maths, there's something beyond your core ability is going wrong. So it could be a major disaster that year, disorganization. Really, you've got to look at how you organize your time and how you study. It's very different to GCSE. You're not going to get as much help, okay? It's up to you to make this go well. Yeah, so there'll be something else, and we could definitely address that. And we'll look after this diagnostic test. We'll look at some of the other things that change going from GCSE. I'll call them precognition diagnostic tests questions, as in we're going to look at it ahead of time and see how it changes so we can be prepared. There's a decent amount of research out there that says people like to see what's coming before they do it, and they'll do better if they can. So the last thing to look ahead is any questions you might have. So anyone have any questions before we start that might be here live? If not, no worries. I'll leave it about 30 seconds and then we will begin the first set of 3 questions. Now, traditionally, you will get 20 minutes for these 15 questions. As you can appreciate, that's a little more than 1 mark and 1 minute. Here, I'll probably just give you I've not thought this part through. I would have thought give you 3 minutes, and that is because of the people that might be here live. Okay, so I'll still do the whole 3-minute thing, and then if you're watching it like as in the replay, you can just fast forward. It's 3 minutes. Don't think any more questions are coming in. So I think we are fairly ready to begin the first 3 questions. Just before we start, you may be very surprised, right? You may be surprised what questions are coming up here. If you're all expecting this crazy difficult set of questions, okay, maybe they are, or maybe they're things that you feel quite comfortable with. But either way, this is it. And if you're good at all of these already, that's great news. It's really good. It means you're ready to start a new year, working hard, and you have the fundamentals in place. All the extras are, they're bonuses. All right, there's no more question coming through here. Last check to just say, get yourself a pen and paper ready, and we're going to start the questions. So I keep forgetting I have to press the next page. There you go. I'm going to give you 3 minutes. Clock has begun. Just do as it says. Okay, time's up. So this is for the people who are here live, okay? That's why we have that 3 minutes to actually do it. We'll go through these right now. We're not going to wait for that. And then we'll get to the next questions in a bit. So simplifying is one of the important skills, but what type of questions? These are 3 of a set of important simplifying questions, and I've made about 8 different sets of questions that I can put in my shop for like a whole set of them if you want these practice questions. So fairly straightforward. You've got like terms, yeah? So the negative 9x plus the 2x, there's nothing we could do with the x squared, and simplifying the x's, and the 4 is on its own too. Okay, so yes or no, okay? It's either correct or it isn't. There's no, oh, nearly. Nope. It's either correct or it isn't, I'm afraid. Careful here, we'll have an intermediate section here, because we want to deal with these brackets first. The thing it's testing it really is this negative, right? So you've got to apply that negative properly. You've got to know the bit mass involved and stay nice and neat. You don't get much space because there's not much to it, but there's enough to do this. So as we expand the negative, that comes in and makes the 4x negative, but it makes, crucially, that's where a lot of people go wrong, the y becomes positive. Now we've just got some like terms. So in total, we have 5x and 9y. Okay, so there's your second one. And lastly, what's the key here? The key here is actually to deal with this first, because you're going to find that fairly difficult. A lot of people try and charge in, and they'll multiply this left-hand term to the term here, the base of this cube. They'll just disregard these brackets. Unfortunately, you have to deal with the expansion first. Okay, so we're going to have to rewrite this question, shall I say, and try my best with this pen. It's definitely not my tablet, but it's something. So knowing that if we have a number on the outside, the indices are going to multiply. So we have x to the 6, and 3 times 1 is 3. Now we don't really have any brackets. I put them there to be clear what I just did, but everything is being multiplied together right now. There's an illusion if they're not. They're all factors. So we can just do like terms. We've got the numbers. The x would be 3 plus the 6, so we've got x to the 9. And finally, y to the 5. So 2 plus 3. There you go. How did you do? You got 1, 2, 3 marks. Remember, in this test, there's no lying to yourself. You have to be honest, and you have to get 100% to pass this. This means that your core fundamentals are solid, and there are variations. These aren't the only questions, but they're defined very specifically based on the same problems that people have year after year. Okay, should we do the next one? I want to just take a quick look at chat because there may be a question. No, if there are questions, you go ahead and you let me know at any time. I'll be there. I think I could put that there this time. Okay. Here's the next ones. There were 3, okay? These next section of 3. They're always going to be 3 minutes each. Okay, let's go. So 3 minutes. As I say, I'm going to wait for the 3 minutes for people who are here live. If you are watching this on a replay, go ahead and skip 3 minutes approximately. But don't hold me to that. I'm not counting perfectly. feel free to shove out some questions into the chat. Be really interested to collect those. I can start gathering my thoughts about them, and we can talk about it as we go along. I think it's about 3 minutes. So this skill is expanding. There are different variations to this, but let's use red. There are, as I said, different variations. These are testing a particular type of misconception. Okay, so these things, if they fooled you, then that's something we need to work on. Okay, if not, well done. This is good news. All right, let's have a go. So we're expanding into this. So the 3x is going to come in and multiply both terms. Fairly straightforward. So we have 3 times 2, which is 6. We have x times x. Should probably put that 6 properly so we don't get confused. And then y is just on its own. Nothing to do. The positive times the negative. Here it means we stay negative. 3 times 22 is 66. Looking for those numbers that are very large to put you off. That's not as large as it could be. I know, I'm not too impressed by it, but they're not usual times tables, right? So getting used to weird numbers is one thing in A level. You'll have to get used to numbers that aren't nice. You know, the answers won't be whole numbers always. And so it's just something we learn to live with. Just like the real world, really. Expand. Okay, so there's many different methods. I'm not going to go into it too much here. We could just do one thing at a time. So we've got the x times the minus x. So we got negative x squared. Then we've got a 4x. So in total, we've got a positive multiplication here. It's okay. So it's like positive 4x and positive 8x. So 12x in total. And then negative 32. So the 4 times the 8. Yes, there are variations. You can put the negative x squared at the end. It's up to you. Some people like to put a positive out the front. But if you're writing a quadratic, you want descending powers of x. And for anyone who's seen a live stream before, you'll know that you can look at the powers like so. So x squared, x to the 1, and the last term is actually x to the 0. So we all know that x to the 0 is 1. So it is a descending power of x. And this is crucial for understanding your differentiation, which differentiation, in my opinion, is the first topic that's truly exciting at A level. And some of you will have done it at further maths. Spoilt your little surprise, but there's plenty more, I suppose. But it is exciting because it's brand new. It's the first time it feels like, wow, this is above average maths. Right, let's just whack through these last two here. So what we got? We've got expanding these. We've got 5, so it's 30x squared. Just had this moment there just thinking about if I can see a pattern here. In fact, you could take a factor out of this. So you can see here that it's very interesting, and I'll do it here. If you're looking for the trick, the 5 can come out because of this factor of 5 in the first bracket to leave us with x plus 1, and then the 6 can come out the second bracket to leave us with x minus 1. And so we could, knowing the difference of two squares, say we have x squared minus 1 multiplied by 30. And that's what we're going to find in a second. We need to expand it, right? So this isn't the final form, but you're going to find that it looks like that. Essentially, we have here negative 30x plus 30x. So the x term doesn't count. And then we have plus 5 multiplied by negative 6. So we have this, which is the expansion of the, should we call it the clever way? The outside the box thinking way. Okay, so there's the end of the section. If you want to see, if you want to get any questions, just, put them in the chat. How many did you get right? It's 1 mark. You have to get it completely, or you don't get it at all, I'm afraid. These are what we call given skills. Okay, if we're all ready then. And this is just for people that are here live. Okay, that's why I'm slowing it down and giving the time. This time I've got a timer ready. I had a bit of time. So I'm going to get a timer ready, give it exactly 3 minutes. That will help those people who are watching this on the replay. All right, let's start. Next section, section number 3. So you've got 3 minutes starting from now. The way I play this is that you have to be consistently good at this. So having one test is not exactly going to say, yep, got it in the bag. It's an indicator. It would be good to see variations in order to demonstrate to yourself that you're consistent. So doing a few of these would be good for confidence. 2 minutes left. Thirty seconds left. Just to remind everyone, this is the silent section where people are doing work live, hopefully. If you're watching this on the replay, moving on. Time is up in 3, 2, 1, boom. Let's go. So we're going to go through the answers now as typical. I think I've moved to orange for this, already changed color. Good, good, good. Okay, factorizing. Remember, here's a tip for you. Don't factorize with a crazy method, like a fancy method, if you can get away with the basic factorizing. This is what we call the basic factorizing. If you look at the question number 8, the first two terms have an x in common, but nothing in common with the number at the end. The second two terms may have a number in common, but they don't have a number in common with the first, unless you're talking about number 1, I hear you cry, which is actually a little bit pointless to divide or use because it just doesn't change anything. Okay, let's get on with the answers. So factorizing here, we're looking for common terms that go into both. We'll first be looking at the number. So hopefully you can see there's an 8 that goes into 24. Just to demonstrate this rather clearly, the 8 times 3 would be the coefficient out the front of the x to the 5. And then at the front we have an 8 times 1 out the front of the x to the 4. So you can see factors have been split up. We're going to factor this even more now, and we're going to say 8 times 3. And how many x's can we get out of both? We can have x multiplied by x to the 4, 8 times 1 again, and we have an x multiplied, or actually just x to the 4. Yep, just x to the 4. Multiplied by 1 essentially. So we can see what we're taking out. We're taking out the 8 from both, and we're taking out an x to the 4 from both. So writing it in factors can be helpful, and we open a bracket. So that's what we're taking out. And the key understanding here is that when you take something out like this, we see what goes into both. To know what goes in this bracket is a division. Okay, so what we took out, we do a division. We do 24x to the 5 divided by what we took out. And that is what goes in the bracket. So 24 divided by 8 is 3. And then x5, x4, you're going to end up with 1x remaining. So the first term in the bracket is 3x. The second term is going to be 8x to the 4 divided by what we took out. So don't be too confused. The reason why it's there is for that exact reason. When people see that it's the same thing, they sometimes don't even write anything. They just write 3x because they think, oh, the 8x, it's already done, so I don't need to write anything. But that's not the case. You have to write that it's some sort of placeholder in a sense, but anything divided by itself is 1. So don't forget that one. Okay, factorizing. Whatever method you want to choose to factorize, I like to do it in my head method. You heard of that one? It's called having done this for so many years, right? But there are so many methods out there, and I like to organize it with a table. If I suspect that this has factors that I could work with, for example, 10 and 11, I'll write down my focus. And I'll think, okay, that's 10 times 11. You'll do it thoroughly. You'll test all of the factors, but I think I can see something working with this. I can see therefore that 10 and 11 get me to 21. So I put it into a format that I am aware I need it in. See, that's like, where did you get that from? Experience tells me it's going to look something like this. And all I want are these numbers. So that's one way of doing it. Of course, there are a number of ways. Do it the way you're happy with, but there's the answer. Okay, it doesn't matter really what the method is. You don't get any marks for it here. You have to get this right. You get it right however you want in the time that you can manage it, and give yourself a tick or a cross. Okay, look out for this one. If they want to test you, whether you really know what you're doing, they'll put a quadratic in like this. Yeah, seems like this standard one, number 8, but it isn't. It's one where you could save a lot of time if you're careful. The essential method comes in 3 parts. This isn't the first part, by the way, but we identify that we have 2 numbers which could be seen as square numbers. Okay, that's 2x all squared. So there's 2 square numbers being subtracted. And because of this, this is the difference of 2 squares. Now here are the 3 steps. You take the first In fact, I've already done it at the bottom here. So let me get rid of that. And imagine I was doing this fresh. We take the first term and we square root it. So what is that? That's 2x. That is the thing that was being squared to get this. Even though it doesn't look like it because it's different format or it's simplified, it is. And then we square the second one. Let's give it a bit of space. That is the second step. Okay, so we've got these two square roots, essentially. And then it goes, the third one is just put them into the format. It's a third one because you have to remember this format. It looks like this. There's an x in both. One of them's a plus and one of them's a negative. That's literally every time. There's something to remember. It's not something to say, oh, look at this question. This is inferred from the question. No. And then keeping, what am I doing? Getting carried away. That's for a standard one. Yeah, like this. So typically you'll have like the x plus fine, but for this one, we're going to say one of them is a plus and one of them is a negative. So actually this is the standard, and what we're going to put into these gaps, should I put, yeah, let's put a gaps. So I'll put in fact I'll put a line so I can rub it out. So where the top of these green lines are, these are going to have elements that we need to fill out. So we kind of know these and this format, and we know what needs to go in there. The only tip I can tell you is that stay in the same order as the original question. So this is the square root of the first term, so make sure that one goes in first, and it goes in both first, and then the second one is here, so make sure that goes second. Then there'll be so much less confusion. You can mess around with it, it's possible, but consistency is going to mean a more calm headspace, I would say. I'm going to put it that way. Okay, so there you go. There you go. Let's get rid of this mess as you figure out how many you got correct. Right or wrong? Everyone can make a mistake. Don't worry about it. It's fine. But what you want to do is maybe do a couple of these tests in a row and see if you're consistently getting 100%. And then there's such a good confidence boost because you have these core skills. Beyond that, we'll talk about that in a minute. Okay, so that was set 3. That was my dishwasher. I actually don't know if you can hear it, but I can. It's wonderful noise. All right, so as I said, set 3. We're going to start set 4 without further ado. Still no questions in the chat, so feel free to ask questions. Answer anything you want. Remember the theme today. Yeah, we're starting this whole session with a diagnostic because I think that is really useful. It's going to give you value for your time. So thank you for coming. But I'm doing this for you. You're going to get so much out of this. This is really reassuring. This is ticking a box. And remember, if you're doing really well on this, that's a really good sign. Okay, don't question it. Just think, yes, it's gonna be a nice start to the year. We're not going to waste months of my life getting this known. We can get it sorted early. So yeah, feel free. And then, as I say, that's the start. And what we're going to be going on to do is a question session. Okay, so this is about your new A-level study. It's already the number one thing actually is study skills. So the things that people are saying that we need to work on are timing and the difference in study. So that'll be for another time. But for now, we're just sort of refreshing ourselves after the summer. So get into that mood of what questions do I have about this great big journey next. And bear in mind that, in my opinion and many people's opinion, A-level maths will be the hardest stage of your life in terms of academia, I would say. Unless you're going to do a PhD, that's hard in a different way. But the shock of doing A-level, I think that needs not underestimating. Right, let's do the next one. Yes, we've got 3 minutes to do this next section, and let's go. Okay, so your time starts now. 3 minutes. Don't forget to ask questions if you want. We're doing the diagnostic test, and this is set number 4 out of 5. You've got 3 minutes to have a go yourself. If you're listening from home, skip about 3 minutes ahead and you'll get the answers. Yes, it is quiet. People like to work in quiet. I don't. Maybe if you're one of those people that don't like to work in quiet, say in the chat. I'd be interested. Okay, you've got 30 seconds left. For anyone here live and doing these questions, 30 seconds. Okay, that's it. For those of you who are on the replay, you're definitely going to be at this point. Welcome back. We have the answers. So, starting from the left, this really puts people off because you have to go to the negatives and be comfortable about it, right? So we're going to work one bit at a time. Essentially, I do this in one though. So remember, these are skills that we expect you to know. So essentially, you should be able to do it all in your head without that intermediate sort of working for the most part. We can do two things at once. Firstly, we want to unite the numbers. What's the best way of doing that? You can think ahead. You've got two options. You either take away 8 from both sides, or you add 22 to both sides. So we'll give you either 30 or negative 30. If I'm inclined to do anything, it's this. I would take away 8 from both sides. In like, that means that this left-hand side is going to be my number side. So the right-hand side is going to be the side where I have the x's, which means I'm just going to have to deal with whatever's happening. So we're going to take away x from both sides. I think we can all agree that having a positive x is better than having a negative x. So that's probably the reason I feel inclined to do it this way. I can deal with the fact that negative division is fine. So divide both sides by 10, we get x equals negative 3. Not a problem. So I'm not going to go too much detail here. I think I'm doing a pretty good commentary in terms of detail as it is. I wouldn't want to do any more. You either know this or you don't. And if you don't, there's more tests. I give you the whole set. So feel free to reach out and grab a set of those. So x is negative 3. Hopefully you got that. Okay, this is a 2-part thing. I didn't change the pen color. I hope you don't mind. I think I will. I don't know why I like to change the pen color. Anyway, I'm going to do that section first. So everything remains the same. So maybe a bit more space for this one. So 12x subtract 5, that's going to stay the same. And then we have 7x, and this is what the difficult bit is. We've got the expansion, negative 9x plus 9. Okay, so that skill coming in again of the negatives. Just be really careful. All of this whizzes around. The right hand side, if you look at these x's, it kind of like go to negative 2x. And then we add 2x to both sides. So all we have on the left hand side is 14x. And then the negative 5, we're going to add 5 to both sides. So that will go across and become 14. If that was too quick for you, then maybe this is a skill you need to develop, because that's how fast you should be able to do this, like rearranging in your head left and right. Definitely some heuristics there. Heuristics are, how do I describe them? Methods that you use to make it's like shortcuts to make things quicker. And maths is all about that, really. It's about efficiency. Right, so we can see here that x is going to have to be 1. You can say, I'm going to divide both sides by 14, or you can just say, well, it's obvious, isn't it? 14 times something is equal to 14, has to be 1. All right, next. You have to get that right, or you didn't, right? Remember, there's no in-betweens. Next, this is so common, and I don't know why people do this. You can tell yourself, you don't need to admit it in chat, but is your first instinct to add 1 to both sides? Having a little fun here, because when I'm like teaching, when I'm tutoring people, this is their number one thing. It's like a rule that they like to violate. You cannot take from this numerator. You have to deal with the denominator first, okay? So in that regard, we're going to deal with the 2 first. So we're going to multiply both things by 2, essentially leaving the left-hand side as 7x minus 1. And the right-hand side gets an upgrade, should we say. So everything is twice. 32 at the end? No. Hopefully you're like, because you are aware. Everything gets multiplied, okay? Same thing again. We're going to rearrange in our head. I'm going to make the right-hand side the x, the location of the x's. So I'm going to take away 7x from both sides. Leave me with x. That means the left-hand side is the number side. We're going to take away 64 from both sides. So end up with negative 65 and boom. Wow, okay. Just reveals itself. Yeah, sometimes that's really nice. Maybe you thought there was another step involved. That was clearly the right way to go about things. All right, so the answer is actually down there. I'm going to move it for you. I'm going to try and move it for you. It would be more accurate. There you go. All right, nice. So those are the 3. You need to get them correct. As I said, no method marks available. If you don't feel confident or you didn't get one correct, you need to do it again. Typically, you'll sit these 15 questions in one go and you get 20 minutes. You have to get 100% on them. And I'm going to try and explain a concept right now that I teach all of my tutees. When you're studying maths, it's like you're in the classroom and, okay, you get an experience to learn. But the biggest impact is what's going to happen at home. And when you're not in the classroom, that's the most time that you have available to study. And if you're not hard on yourself, like if you're not making your life difficult by keeping your standards high, that's where things can get difficult. And that is the difference between someone who self-studies and someone who is just fed their study. You know, at GCSE, a lot of the things you'll learn get just put in front of you. Okay, you don't have to do much effort. For A-level, you have to put in a bit of extra effort, especially if you want to get above a grade D. And this comes in the form of being hard on yourself. So I'll give you an example of these tests. I would take one test for 20 minutes and I would work through it. If I got one question wrong, I could take 2 attitudes depending on how I'm feeling. I could say, in both cases, I would say, okay, it's fine. One question is wrong. This is a great learning experience. It's fine. Don't beat yourself up about it. But you have 2 attitudes. One, that's good enough. And two, and to me, that's gambling. Like maybe that skill's important one day and you wish you'd ironed it out early. And the second is that that's not good enough. And that sounds obvious. And then you do it again. And you say, I'm not getting up from this desk until I can do this properly. I feel like it's an analogy for sport as well. And if you're sport people out there and you want to perfect this move, yeah, let's say it's a badminton lunge or whatever it is, a trick with a football. And like you just don't give up. Like you've got resilience. And resilience and grit, you know, like not giving up, that's fast becoming one of the most important skills in life. Look at me preach. Let's go. Next section. Section 5. Okay, section 5 is coming up, and give you paper and pen ready. No calculators, just to remind everyone who's joining it a little bit later. I'm going to give you 3 minutes to do this next section. It's the final section. Best of luck. Your time starts now. Don't forget, if you have any questions, please do ask them. Don't be shy. Any questions about your upcoming A-level study? You may have some. Okay, you've had 2 minutes, 1 minute left. Trying to imagine you sitting there, working away right now. Making an effort. It's good stuff. Three, 2, 1. Okay, welcome back, people who are watching the replay. You found the right place. I had a pin one of the chats. It says, math is my favorite subject. That's really good. We all have to have a favorite of something. Okay, number 13. This skill is it's kind of why is it difficult? It's difficult because for some reason it's not practiced enough. And there's a very tricky idea around the negative. That if you put the negative into the calculator or in your head, you see it this way versus this way. Okay, so two very different ways of looking at it. This clearly is the second way. So we have to be aware that brackets are going to be really useful for understanding here. Time to change the pen color, but oh yeah, we haven't done black yet. Okay, so the first one, we all should know the cube root of 27 is 3. We'll all be very happy if this came up as the actual diagnostic test, right? But it's all about being hard on ourselves. If this one you found easy, there are many variations of the diagnostic test that I would strongly encourage you to be aware of, just to cover all bases. And then we're going to take away the result of 2 cubed, which is 8. So in total, we're at -5. Good job, everyone. This, I'm going to tell you right now, who thinks, yeah, I'm really good at substitution, I got it in the bag. Substitution. A lot of people do. A lot of people think this is straightforward and they don't bother practicing it. But really, I'm telling you now, it's the #1 thing that people make mistakes on. And at A-level, your substitution is not as easy as this. This is easy, okay? Relatively speaking, I need you to be prepared for that. There are more complex substitutions, especially if you're studying further maths. You have to be very organized and substitute correctly. Really the only way, and I can say it over and over, but really the only way is to use brackets. You have to do that bracket thing properly, okay? So what does it look like with brackets here? Well, it's whatever x is cubed and then multiplied by 3. And then whatever x is over here squared and multiplied by 8. We're told that x is 3. So we can go ahead and put that in. We can work out roughly what we have going on here. So 3 squared is 9 times 8 is 72. Let's do it the right order first. 3 cubed is 27 times 3 is 60, 20, 81. And what did we say that was? 9. We said that was 72. It's got 9 times 8. And then we do the subtraction, which is a lovely 9. There are many ways of doing this. This is my way of doing it. And this is a very simple question. Let's not beat around the bush. The main thing I'm trying to get at is that this is simple to demonstrate initially. It will get harder. Just be disciplined about making sure that you're happy with this. All right, the ultimate, the negative substitution, okay? So we're going to do the same thing that I did last time. I'm just going to make sure that it's all in there as much as possible. So 3 plus, and then we've got a whole blank. And what we're putting in is -2. Okay, so then we are being organized by dealing with one thing at a time. So -2 squared, as we hopefully realize, is going to come positive. So that's positive 4 from this one, times 10, which is 40. And over here, we've got cubed. This is really it. Okay, this is where people go wrong. -2 times -2 times -2. If we do these first two, it's 4 positive. But then we're going back negative. Okay, now I'm sorry if that's really obvious. It probably isn't to some people. But we have to, I mean, this is used so much that it's worth remembering that we go back. So when it's an odd index, it becomes odd overall. So the result of this is -8. Essentially what we have here is -8 multiplied by -3, if you want to know, if you want to simplify that. So that's again positive 24, just like so. And then plus minus only becomes negative when those signs are right next to each other. Brackets don't count. And they are, so we're going to take away the 2. So that's going to be 64, take away 2, 62. So you get 1 mark for that. But, you know, aside from me talking and slowing everything down, I think you can manage that in a good time. So there you have it. You've got your 15 questions. If you didn't start at the beginning, go back and watch the replay, if you will. Very, very nice set of questions. I sell a bundle of these in the shop. In fact, just after this live, I will be putting it up in the shop. You can buy a pack of 5 of these practice questions if you just want to make sure, if you've got anyone wrong, or you just want to be sure that all the variations are covered. Feel free. I'm going to put it up as cheap as possible. Or it will be included with a tier 2 and above subscription at Patreon. I probably should take a moment here before we move on to the more difficult questions, like the preview, the advanced preview, the kind of things that GCSE turns into. That I attempted to run some sort of competition. I put the full terms and conditions because that's what you have to do. Crazy ideas. But the competition essentially, I'm trying to think where it is now. I think it might be in the advanced preview, the kind of things. No, it's not there. Well, anyway, essentially asking to follow the Patreon page is, you can do that for free. It's like called Join the Community, and you can get free updates, or if I give out the free resources, I'm starting to use them to distribute resources, because I don't want to be putting it on my personal Google Drive anymore. So yeah, there is a shop for the things that have taken me 20 to 30 hours to produce, and then there's some freebies as well. And if you do sign up for Patreon, you get some merchandise, which I think is an amazing. I've got some samples, and I think they're amazing. A great tribute to the year of study. It's going to be a hell of a year, and I'm going to be there for you. You've got some questions, you put them out there. There's a good community, and I'll produce content for you if you need it. So do please consider. But part of the competition is to join that community. Make sure you're subscribed to YouTube, and tag 2 people in the comments section of this live once we're finished on the live, and you will be entered into the competition to win a set of exam questions, unique practice questions. Let me think. To put it in context, there are only a certain number of exam questions out there. There's the past papers, and there's not that many. You quickly run out. So to have a workshop of professionals developing new questions that you can practice with, very valuable. So I'm hoping to continue that for you guys. All right, so enough of that. Let's get on to the next bit that I have prepared for thee. So the next bit is essentially what's coming next. How does the GCSE compare to the A-level? And I had a little think about it. And apart from these diagnostic questions that we've looked at so far, it changes in quite an interesting way. So at GCSE, you may have questions like this. So SERDs would be the first type of thing that changes. It gets a little bit harder, as you can appreciate. Call this an advanced preview. So everyone should be able to do questions like this. I'm not saying this is the core issue, because you will learn this again at A-level, right? This is something that gets revisited. The diagnostic we just did is totally separate, but these are still really important in their own sense. The key here, I guess I could go through a few tips. I wasn't going to go into too much detail, but just make sure you can do these questions. Have a go now if you wish. They're like a tick list for GCSE, but I'm going to show you how it changes. Essentially, this would be looking at factors. So root 7, root 2. This would also be root 7, but root 6. No, sorry, root 9. What am I thinking? And so you can do, finding factors in both of those and adding it together as much as you can. Simplifying with the 80, same thing. We're going to be thinking about factors that go into 80 that are also square. So, thinking about those factors, you can write them out. So what do you have? 4, and these are square numbers that are going to be useful for us. 25. 16 really jumps out at me because of experience, I suppose. But what could you multiply 16 by to get to 80? So you're thinking 5. So if I had 16 root 5, the 16 is essential as a square number because it becomes 4, right? So we're looking to get the smallest number under the surd. As I said, I don't want to go into too much detail here. And lastly, in order to simplify this, a lot of people just see the word rationalize, right? But essentially, you are simplifying this by doing it. So it could say rationalize the denominator or simplify. We're going to multiply the top and the bottom by root 11, which will give us an interesting result. So 55 root 11 all over root 11 times root 11 is 11. So that simplifies down to be as such. All right, so there's a little preview, brief overview on how it works, just in case you didn't know. And that's essentially GCSE. How this changes and gets upgraded at A level is to this. And the question is still the same. You have to simplify this, you have to rationalize it, whatever they're going to say. But this would be dependent on the conjugate. So a special method. What do you multiply the bottom by so that you get rid of the surd? And some people are thinking, okay, well, root 3, that works, but then that becomes 2 root 3 when multiplied by this term. So it doesn't work in the long run. The upgrade is to know the conjugate, which is 2 plus root 3. So we're using the denominator to define what we're going to multiply it by. I'm not going to go into expanding or multiplying surds, but essentially you're looking at something like this, and you have to multiply that out. Don't take any chances, do it properly. What you'll find is this becomes rational, okay? So you've got, I just should do it very quickly, 4 plus 2 root 3, if you do the first two, and then you've got negative 2 root 3, as you'd expect. And you've got to appreciate that root 3 times root 3 is 3, and that's going to be negative. So all of this goes in the middle, and 4 take away 3 is 1. Beautiful. So the denominator at the bottom becomes 1. It doesn't matter what goes on the numerator. The numerator is a whole other expansion, but the denominator is now a 1. Just trying to make it look like a 1. And happy days. All right. So this is how the A level gets upgraded. This is in chapter 1 of your A level, actually, A level pure. It's the first thing that you look at. Next topic. So GCSE indices, we might have things like this. This is the ultimate question set, right? We just looked at this skill, knowing that we get 125, m to the 6, n to the 12. Okay, that's pretty straightforward index rules. They apply to the indices in there via multiplication. And here we have two things to figure out. It's a fractional index, and we know that that means we're going to cube and square. I prefer to cube it first. So 27 cubed is 3, squared is 9, multiplied by this deal here. You've got to remember that the negative means 1 over. So 2 to the negative 2 essentially becomes 1 over 2 squared. See what happened there? The negative power index, the negative part, came away and turned into 1 over, and the denominator is whatever was left. So essentially there we've got 1/4. And that becomes 9 over 4. There you go. How does that change at A level? We're using the same sort of rules, but we do a lot of this, I tell you. So this is mainly for differentiation, for calculus. You will be doing a lot of the sorting of the indices. And at the top, we have some special, what we call, I put some of these on my Instagram for practice, but these will be index equations. So have a look at this first one. We're looking to see what we have in common here so that we might rearrange it. And some of you might think logs, and yeah, that's fair to say, but you can do this without logs. There's a bit of knowledge on how to equate the two sides. So we can say that this was 2 cubed, x minus 2, and then 64 is 2 to the 6, I believe. And therefore, let's do another line actually. We can multiply that 3 in, so we get 3x minus 6 equals 2 to the 6. And therefore now, because these bases are the same, we can equate the two tops. And then we get 3x equals 12 and x equals 4. So that's how like what we do with indices, where we go on to. And this other one here is knowing that we can write this as separate entities. So like this, plus 1. It's a very good example actually, because was that 3x to the 3? Let me get that correct. Because this demonstrates 3 or 4 different rules. So good to see this one. And 3x3. So the first rule comes from, let me go down a bit. First rule here comes from the fractional thing. Like, how do you deal with this, right? How do you simplify it? Well, 2/3, and you could see this as 2/3 multiplied by x squared over x cubed, right? Separate it out. So the 2/3 is just going to be 2/3. The question is, what happens with the x's? Well, x squared, you're going to do take away the indices. So 2 take away 3 is -1. And most people prefer to put this like that. If you're not putting it in index form, you'll need to see it as 1 over x. So that would be 2 on top. So you've got 2/3 multiplied by 1 over x, and on the bottom 3x. So it depends. I'm just going to leave it in index form here, but fractional form is also pretty cool. Depends how you like to work. Let's move on to the next one. So you'll notice that it's negative, but we could deal with just this bit and the negative later. So 6 divided by 3 is 2. Nice. But here we're going to have to appreciate that root x is x to the half, and then x to the 3. Well, that's not very nice at all, but essentially it's just a takeaway sum, right? So half take away 3 is -2.5, which is -5 over 2, which is probably the best way of writing that. And there's a whole thing about like how to write this properly. It's along the same lines as the x to the 1 here. So if I wanted to write it as a fraction, this 5 over 2 would first have to turn into x to the 5 over 2, and that's 1 over. And then we decide what happens next. If it's being multiplied, maybe it'll go to the numerator or whatever it is. So essentially we figured this middle one out. And here, you could leave it like this if you want it in fractional form, right? But we're going to think about what this means. If it's 1 over, it's 3x to the 3 to the -1. And if we want to just sort of bring that in, this -1 is going to multiply the index of both of those. So that's become -1. So that's actually 1/3 multiplied by x to the -3. And you could look at that. You go backwards as well, right? You could say, well, x to the -3 is 1 over x cubed, and that brings us back to the original. But if we want it into some sort of index form here, then we would be writing 1/3 x to the -3. Why is this useful? When you do calculus, when you do differentiation or integration or all that sort of stuff, you need to know very clearly what we call in front here the coefficient and the index, because the relationship or the method relies heavily on what you do to those two things. So if you make it very clear and separate it out rather than it being in fractional form, you can perform your differentiation. So you remember that one when you're in your differentiation class right at the beginning, and other people are having troubles, and you remember, oh, I need it in this form first. You're going to be a little bit ahead. All right, so that's how we sort of transform, and we need to be thinking this is the kind of complexity to begin A-level study on our indices, okay? I don't see any questions in the chat. I guess there were a couple of silly ones up there. But if you do have any, please feel free to ask. I will do my utmost to answer. And if not, I know that I know somebody that can help in like the most professional way. Right, let's have a look at another topic and see how it changes. Good old simultaneous equations. Anyone really enjoy them from GCSE? It's really nice when they're like this, isn't it? Because you could do that whole method where you're deciding, how am I going to, what am I going to be adding, or am I going to be taking these away? And, it's all very well. And your calculator can deal with these. So all of your A-level exams are calculator based. And if you get the Casio FX, let's have a look. I might link that in the description for you later. But the Casio FX991 used to be the old EX, and I promise you it's better than the new CW, right? CW is probably class whiz. And it's a new one with rounded buttons that a lot of people don't really like. But I did notice on Amazon recently that 900 of them sold by one vendor on Amazon. This was just in the last month. So people are getting ready for study at A-level. The CW doesn't do that much extra, and in my opinion, it's a little less user-friendly. But any calculator you end up buying, you will just get used to. There's more guides on the EX out there than there are the CW, but check those calculators out. You can solve simultaneous equations using them, right? So the equations that are simultaneous at A-level, they will not be like this nice numbers. The first change that you'll see is that it will look something like this. Okay, so I'm just adapting this. It doesn't mean to say that this question is going to work, but you'll notice that you don't have all the numbers. Unfortunately, your calculator cannot solve them if they're algebra like this. But this is where we're headed with the simultaneous equations. Because you allowed them in the exam, they won't allow you to use it and get 3 marks just for typing stuff in the calculator, unfortunately. That was a good thing, though. Nobody wants to cheat. I know. Well, okay, that's not fair. Nobody should want to cheat. Nobody needs to cheat, but it's always a temptation. It just doesn't do any good in the long run. Right, this is what you're used to anyway. So let's look what A-level does to change things. And there's many ways that it changes things. This is just one thing to consider to give you a nice preview. We might say something like the line L1 has the equation blah, blah, blah. The line L2 has the equation blah, 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 blah. Find the area of the triangle formed by these equations and the y-axis. So you're going to kill 2 birds with 1 stone here and say, you're going to have to be able to sketch. Whenever I interview people for level 3 courses, and they come from across the world, and we interview them online, problem that I often see is they don't understand the difference between sketching and plotting. Plotting takes forever. It's where you draw something, maybe you draw a table to give you some coordinates, but you draw it so accurately and you define the axes. Sketching is like the new norm. I don't really think they ever ask you to plot something at A-level. Sketching is where it's at, okay? So all you need to know for a sketch is where it crosses the axis and a general shape of it. So we're going to do a little bit of sketching here. To sketch it, we need to get these into the proper format, which is simply y on its own. So we've got 16 over 3 minus 2 over 3x. And this bottom one, let's get rid of that sketch so we're not confused. It's always nice to start with the sketch so we know what we're looking at. 12 divided by 4 is 3. Don't let me get caught up by a question like that, please. All right, so what do we know so far? We've got intercept. So 16 over 3 is approximately 5.2, right? No, you're screaming at me. That's totally wrong. Thinking about dividing it by 5. It's divided by 3, so it goes in 5 times and how are we going to write this? all right, it doesn't matter. I'm just going to write it like that. It doesn't actually matter. It's only rough. And this one is got an intercept of 3, which is fairly straightforward. So let's just draw an axis. And we'll say, right, we've got an intercept there of approximately 5.3. We all know that it goes on a bit longer. And we've got another intercept down here of 3. So it begins to unfold. We have one straight line. How do I know it's a straight line? It's only at x to the power of 1. But it's a negative gradient. So it's going down. And it's the one that crosses at 5.3. So we've got some gradient going down like this. We don't need to know where it finishes, but eventually it will cross this line here. And that could be useful to find, maybe. The second the second equation has a positive gradient, and it's going up from 3. As you can see, it's just rough. We don't need to have it perfectly drawn, but this is roughly what's going on. And conceptually, we need to find the area of the triangle that's in here. So you may have some thoughts about how to do that. Generally, with a triangle, you need the base and you need a perpendicular height. Okay. And then we say half base times height. What is the base in this triangle? You've also got to be careful at A level where you have a triangle that does this. How do you find this height? Because if I looked at the difference between here, let's say it's 3 and 5, that is not the length of that diagonal. That's the length of this horizontal. The diagonal is probably longer. And so, well, it is longer because it stretches further, right? It's not going straight across, it goes up a bit. So in that sense, you have to be very careful. You have to be in line with the axis. And that's essentially what I'm getting at here is a pitfall, but it's not an issue for us because the base is in line with the y-axis and the height of this triangle is going to be an x-coordinate here. The x-coordinate is clearly where these two cross over. So, you know, you could put this into a calculator and find that x-coordinate, which I may as well do right now. The calculator, if you're using the FX 991EX, has a function on here called equations and then simultaneous equations with 2 unknowns. And it asks us in the format where we've got our x's and our y's and then our numbers. Okay, so we need to have it in that format. So let's keep the y's positive. So we've got 3y in the top equation, and then if this 2x came over, it would be a positive 2x, and we'd have a 16 on the right. The bottom one will have a positive 4y, and we move the 2x over, it becomes negative 2x, and the 12 remains on the right. So let's put that in to, if you've got your own calculator, have a go. Do it along with me. 4 and 12. So we have an x value of 2 and a y value of 4. So we're definitely fully aware at A level that when we find the solution to simultaneous equations, it represents a coordinate, and the coordinate, let's use a different color, is up here. 2, 4. So that could be very useful to our endeavor. Let's use a different color now. We're moving forward. Clear some space. What do we need? We need the height of this thing, right? So we're going to fill out half times the base. The base is going to be 5 1/3, take away 3, so that's 2 1/3. How we write? I'll just write 2 1/3, it doesn't matter. And then multiplied by the height, which we found is the x part of this particular one. Well, that's really useful. The 2 and the half cancel out, so we get 2/3. And, you know, you could call it units squared, whatever the units are here, but they're typically quite abstract, so you don't need the units at A level a lot of the time. Unless you're doing the applied stuff, you know, like mechanics, decision, statistics, where it's going to be fairly clear. If it's in pure maths, you don't generally get away without even writing units squared. But, you know, if we can be extra, we can have high standards. So this is the difference. Yeah, this is basic given to you. We mentioned that some of these might turn into letters, algebra, but that this kind of problem solving stuff is where it leads, using the result in geometric sense. Okay, so that's what happens to simultaneous equations. No questions? Just checking if there are any questions. No one knows what topics are coming up. I didn't pre-release it. So the next topic is quadratics. I love quadratics. If you want to do good at GCSE, you probably realize that quadratics, is fundamental. What happens at A level? Same thing as we just talked about. We add letters. So you've got your basic quadratic. You need to solve this using the quadratic formula, perhaps. But don't forget, your calculator can do it. So in a sense, because you always get a calculator, they're not going to test you on your ability to solve it. This will be part of a bigger question. If you get it slightly wrong, you get it wrong. It's like, oh, it's nearly there. I'll give you a half mark. Or no, nothing like that. So you need to get it right because the calculator is there. No big deal. Let's brainstorm quickly. How would we solve this? Well, it says here use the quadratic equation, but you could complete the square, which is one of my favorite methods. You could use the quadratic equation. If the numbers work, you could factorize. What else could you do? And by the way, there's multiple ways to factorize. Like, I know 3 at least. So there's that. Or you could use your calculator. That's about it, really. The methods that you realize. There are alternative forms to this. They're sometimes subject to condition, but you might find some heuristics on doing it. In fact, I don't need to rub that out. Let's go down to the A-level question. We take this a little bit further by saying the following equation has 2 real roots. And if you ever see this means we're using something called the discriminant. If you've done further maths at GCSE, you might know this. There are 3 results. You can either have more than 0, equal to 0, or less than 0. The discriminant is the part of the quadratic formula, and we should probably write the quadratic formula out. It's like etched into my mind. All over 2a, important distinction. The discriminant is referring to the part under the square root, the b squared minus 4ac. And as you can see, it poses an interesting issue. If we have the square root of a number that's positive, that's okay. We can square root positive numbers. You probably know growing up that there's a very serious issue with square rooting negative numbers because the calculator gives you an error. This is not the case if you are studying further maths. You'll realize that it's just another number. It's just another set of numbers that we're not really well versed of dealing with originally, but now we've developed a whole thing around it. Complex analysis is vast. It's huge, very, very interesting, and probably the second most exciting new topic at A-level is complex numbers, in my opinion. So if you have calculus for normal A-level maths, complex analysis would be for further maths the most exciting new topic because it opens up some part of the world like an adventure, like an unknown part, like a secret that you never knew was there. Nobody bothered telling you. That's way too difficult for you to understand until now. And then suddenly you're in the club, right? So this is a fascinating topic and we're going to have our own ideas on it. It's a fascinating thing because you can't see the complex world, not really. It's a whole interesting thing to try and figure out through trial and improvement. So anyway, enough talk on that. You could see that there are 3 possible results. Now, if it was 0, then this whole thing wouldn't exist, and therefore we would have one solution. If this was 0, the plus or minus wouldn't make any sense, and therefore there'd be one solution. But because it's a quadratic, we call it one repeated solution. So we have these 3 results, and you need to be aware that if it's talking about 2 real results, That's this one here. Okay, 2 real results. Oh dear, that looked. Let me make that a bit more clear for you new to the A level. This little capital R with the extra line means real. It's an abbreviation because you don't want to keep writing real all the time, right? And the more abbreviations you learn, the happier you are going to be on independent study, because all of the papers and books will use symbols. Here's your first one. So this is real times 2. If we have 0, we have a repeated. And here down the bottom, this is where we don't have any solutions at all. Okay, so we might have in a question that have no solutions, unless you're studying further maths. But we would say no real solutions for the bottom one. Okay, in this case, the question is asked for this one. The most often one you're going to get is that they're repeated roots, because it forms an equation, because you can equate it to 0. This is what we call discriminant analysis. So you couldn't just straight up solve this quadratic because it's got a k involved. But what you have been told is a fact about the discriminant, so we're going to use it. What is the discriminant for this particular thing? Well, looking at the quadratic, we need to figure out what A and B and C are. So let's just write that down. A is 2, B is K. And if we move that 7 over, because it needs to be in a format where it's equal to 0, we have that C is equal to positive 7. For the discriminant, it's this, just that part. So that's going to look something like K squared minus 4 times 2 times 7. So that's 14 times 4, which is 40 plus 16. Is that really? No, surely it's not that nice. 8 times, oh yeah, it is. Okay, fair enough. So K squared minus 56. I did 8 times 7, there's one other proof. And what we do know, because they're 2 real roots, is that that's going to be more than 0. That's what we do know. It says here, find the smallest positive integer, that's whole number, value of K. So it looks like this is the equation that dictates how the suitable range for K, like what K could be, is the relationship defined this way. Let's rearrange it like an equation, like using the correct symbology. If I was just writing like this, you wouldn't understand it. Clearly, clarity of communication is quite important. 56. Okay, so K squared has to be more than 56. So if we square root both sides, I could talk about 64 being the square root that I know is closest to 56, and therefore it must be a number which is slightly less than 8. But if you put it in your calculator, you'll get 7.48. So it has to be an integer, so that's not going to count. So K are all the numbers that are bigger than 7.48. That's 8, 9, and 10, etc. So in this sense, we're using 8. Okay, so it looks like there's a lot of possible values that would work for K. So this is not a unique solution, but this question asks for the first. So we're going to go with 8. Let's say K equals 8. Really cool. So when you notice that we're talking about these roots, go for discriminant analysis. And then, hence, this is really cool. If you want to learn the inside like terminology, hence means use what you've done already. All right. And sometimes it says hence or otherwise, because it's not going to hold you back to say, oh, you have to use the previous one. But hence is a clue that you're going to make your life easier if you do. So let's use what we just did, K equals 8, and put it in 2x squared plus 8x plus 7 equals 0. And to find the 2 roots, we're just going to use whatever standard methodology we're using for quadratics. So if you want to do it via your factorizing method, do you remember that method where you do 2 times 7, right? Which is 14. And then you're thinking of factors that will get you to 8. That's not going to work here because there is no such thing. This, and you'll realize this at university as well, there's only one sure method that will always get you a solution to a quadratic, and that's the quadratic formula. And at university, it's pretty much always the quadratic formula. You get so quick at using it, and it's important to have that go-to. And maybe you want to abandon factorizing altogether in favor of the quadratic formula, and then there's only one thing you ever need to do. Get really good at it, right? Up to you. But we can solve this if we go to the Casio equation, and then polynomial. It's got a degree 2 because it's a quadratic, and we put in the coefficients of the 2 and the 8 and the 7 into the blank boxes, and you press enter. You will get something that looks like this. Root 2 over 2. This is perfectly fine at A level. This is what we call an exact solution, because it's written. It's not a decimal that goes on forever. It's written clearly, concisely, using our friend the surd. If you press the SD button, you will get it as a decimal, and typically that'll do as well, because our life doesn't really go beyond 2 or 3 decimal places, and you can write it as a decimal place. But just get used to giving answers like this. There's nothing wrong with it. There's not beautiful little whole numbers like +3 and -4. Those gone are those days, and brilliant for it. Our brains are expanding and becoming more complex, and it's a good thing. Where are we up to? We're finding the 2 roots. Yeah, so if you're doing a calculator, just press enter twice, and how do we write this? We could say x1 and x2. You can write an or in between, or you can write an and in between, because they're both valid. Or depending on the solution you're after, you might write or. It's up to you. Negative 2.707, blah, blah, blah. Okay. So that's the difference. Algebra and discriminant analysis. So those are the kind of problems you're going to be looking at. Let's look at the next one. And this is the last one that we're going to look at today before we take some questions, if there are any. And if there are not, don't worry. You don't need to... you can pin some questions in Patreon on the main board. You could put them in the comment section of this video. You could have a look at Maths Explained. I'm just going to write that down here. So if you want to check out a really cool maths channel, you can check out Maths Explained. And I am in the Discord there, along with some brilliant people who are there, who are really kind, willing to help, and Maths Explained. Great community. Come along, pose your question in there. Doesn't have to be now. It could be any time when you think about it, but do get involved. It's a great place to be. Right, finally, vectors. I said it. Well, vectors get pretty, they used to be bad. If you're studying further maths, they do get bad. Enjoy that. I love vectors myself. Anything that you find difficult or stressful, learn to love it. And then it doesn't control you. You have the power over it. And suddenly you find yourself liking it. And it doesn't cause you stress. Okay, we don't have to truly like it, but it just doesn't cause you stress anymore. Vectors are a brilliant thing to learn to love. So at GCSE, we're looking at basic addition. What we do, work across the top here. 7 plus 3 is 10, take away 5. And we have our basic 2 by 1 vector. Where we're up to 5, yep. And then 7 plus 10 is 17, take away 2 is 15. And this represents a movement, right? So the top represents an X movement and the bottom represents a Y. So we're going to go across 5 and we're going to go up 15. And the resultant is this. This is a basic diagram. You can talk about the angle that's involved here. And because it's a right angled triangle, you could use tan. So the relationship is tan theta equals the opposite over adjacent, which in this case is 15 over 5. And you can find the angle that way. That's pretty advanced, but that's essentially what's going on. And if you want to multiply one of these vectors, then it gets multiplied. So find an expression for 2a minus 3b. Let's call it in C. So 2 lots of 3, 5. Subtract 3 lots of 1c. What does that equal to? Well, firstly, we're going to multiply the terms, so 6 and 10. both of them get multiplied by 2. And then 3 and 3c. We could just do like terms. 6 take away 3 is 3. And 10 take away 3c is 10 take away 3c. It's just an expression. I wanted to put that in there to show some sort of generalization, but essentially it doesn't have to have algebra in there. You're just adding or subtracting like terms. How does that change for A level? Well, there's a couple of major concepts which are, I think, really important. The first one is magnitude. So looking at the 3, 4 here, we have 3 across and 4 up. That gives a resultant here. This resultant is the vector that we're talking about. The magnitude of that vector is going to be the length of that diagonal. So we can use Pythagoras. We could see that we want the long length of a right angled triangle, just like this. And as our standard method tells us, we have 3 squared plus 4 squared, and that's going to be 9 plus 16, good old 25. And that's equal to the long side squared. So we are going to square root that. Okay, so 3 squared, essentially we can write it like this to save myself some space and time. And the length is 5. So we know that the magnitude of that is 5. If we said that this point was A and the top was B, we could say that A to B is written like this with an arrow. And if we want to find the magnitude or the length of that line, we put 2 vertical lines either side, like a vertical bracket. This means magnitude. It means find the length of it. And a lot of the skills, they center around Pythagoras. It works in 2 dimensions, 3 dimensions. So if you had 3, 4, 5, you would be doing these, and let's say the magnitude of that, you would be doing 3 squared plus 4 squared plus 5 squared. Okay, so it extends to higher dimensions as well. So magnitude, that's great. Second thing is introduction of what we call a special type of vector, which is totally out of my head at the moment. What's it called? Yeah, well, I'm not going to go into unit vectors, but they are vectors. As you can see, we're using terminology from the previous section. That's why I sort of had to lead it into this next bit. But it leads us into these types of questions where we have to, and I'm not going to reveal it now because I actually want to set up the problem and see if you can do it without that terminology. But we're going to be, looking at this. Now, what exactly would you do to answer this question? You've got 2 points and you want to find the distance, the magnitude between the two. Think very carefully. I'm aware that it will probably take a little bit of time. So I'm just wanting to give a decent amount of time to have a little think about it first. That's all. But we will be looking at this very shortly. Okay, that's better. My wires are not on top of each other now. Okay, now you've had a little bit of time to think about it. What would you do? You might want to plot these two, right? You might want to think, okay, so we've got one bit that is at 1, 2, and 4 minus 2 is definitely across more, but it's lower. So you could see that as coordinates, and you could turn it into some sort of right-angled triangle. And we're going across 3, we're going down 4, and so that distance there is a 5, right? So we could do it that way. I want to introduce a concept that allows us to do this using only vectors. And it allows us to do a lot of things, actually. It's the most important rule that we have. Now, if we had a vector which goes up like this, and this vector here is vector 1, 2. Okay, so this is vector M. And this vector here, look at that, this is amazing, amazing. there, let's just readjust because we can, is vector n. So it's like 4, goes across 4, -2. It doesn't matter necessarily where this is in space. I mean, I think for your intuition, I should probably redo that so you can see it a bit better. It doesn't matter, essentially, but we do have a situation where it is further along, but it's down here, right? So it's -2. I don't want to get rid of the question, so I don't want to go too far, but we'll go to about there. And so we're thinking, like, how do we get this magnitude here if this is m and this is vector n? Sometimes you can underline these two. Well, m to n goes this way, and in traditional GCSE terms we would want to get straight from m to n, right? But how would you do it? We couldn't go there if we didn't have a direct vector there. We had to go via the vectors that we knew, right? So m to n would have to go, let me use a different color, starting from here, which is this point here, m, down to n. We'd have to go backwards across m, and then positive across n in order to get there. So if we're talking about the vector itself, m to n, describing it in terms of vectors, we would have negative m vector and plus a positive n, which if we rearrange them so the negative isn't at the front, we get this really lovely result. m n is equal to n minus m. Okay, that's actually a really important result. We just switch them around. I know it sounds weird at first, but this is what we call position vectors work. If we have a vector that goes to the 0, 0 point, essentially the elements of that vector, and we'll just have a quick look at this one. It was 1, 2, 1 across, 2 up. Essentially, the elements of that vector are also the coordinate at the end of that vector. Ta-dum! Very important. Let's write that down. Position vector. Can you think why they call it position vector? It's positioned itself at a point of reference, just like a coordinate system has this. The same thing. We go from that point. A position vector starts from the origin, the 0, 0. And that means that at the end of that vector, the coordinates are exactly the same as the dimensions of the vector. So this is the new thing. This is what is new at A level. So rather than this question being about these coordinates, you may get the vector instead, and it might be 1, 2, and the other vector 4, -2. And you've got to realize that if you want to find the distance, like the vector mn, that's going to be the vector n. I think I've mixed them around, actually. Let's not confuse you with that. They were supposed to go the other way around because I've written them underneath that formula, which switches them around. So the vector n, which was 4 - 2, and then take away the vector m, which is 1, 2, and we get the vector mn. So 4 take away 1 is 3, and -2 minus 2 is -4. The good thing about this whole process is, even though there's negative, because we end up squaring it, all distance is positive anyway. But look, 3 and 4, just like from earlier when we were looking at the coordinate way of doing it, we got the 3 and the 4, we square them, and we found the length was 5. It's the same thing that's going to happen here. So we found that the vector is 3, 4. And we did that based on the fact that we have a position vector. So we go down towards the origin and then up across to n, and that will allow us to find that. Now, the last question is to find the magnitude using the new notation. That's the length, mn. So we could put mn into vertical brackets, and that would be the equivalent of squaring the elements of the vector, which is -4 squared, and then square rooting them. Do it properly, why not? That's going to be 9 plus a positive 16. It's going to be the square root of 25, which is 5. And we knew that because we did it via different methods before, but the same thing works with vectors. So vectors they get a lot more fun at A level. One thing you'll be doing at A level is the geometry side of it. The other side is proof. I can tell you that in year 1, the proof of how you get from one point to the other is in 2D. In year 2, it's the same thing, but in 3D. So if you're happy and you sort it out in year 1, then year 2 you're going to be very happy indeed, because it's just an extension of the same methodology, which is highly reliant on a skill. Should I put it? Yeah, I'll put it here. Called equating. Okay, so we find two expressions and we equate two equivalent expressions. I'm telling you, 90% of the vectors questions are that. So there's a gift for you. Have we done everything we need to here? Yes, pretty much. If you're studying further maths, this is not the end of it. You're going to do something very beautiful. I'm going to talk about it very briefly here. You've got your straight lines typically, which is mx plus c. And the mx plus c refers to the c where it crosses the axis here, and the gradient, which is the dy over dx. Okay, how steep it is. And one of the first things you're going to do is use vectors to define lines. I love vectors to define lines. I'll do it with a different color really quickly. Essentially, the y equals mx plus c describes every point on this line, okay, with the relationship which is set out in the equation here. And that's what we need to set out to do with vectors. We need to be able to get to any point on a straight line using vectors. So we start with a position vector because it goes from the origin, and we get to the line. So the first thing is to have a vector that gets us to the line. And R is the equivalent letter, like with Y, it goes on its own. It represents a point on the line. So maybe if I just get rid of that color, I'll change over to orange, because all of these points on the line are R. Sorry if you used that same letter twice, but they are R. And then the position vector, which gets us to, call it A for now, we don't know what it is, it's just a point on the line, isn't it? Because we remember that the coordinate, let's call it 3, 7, can turn into a position vector, and we can use it in our vector equation. So we got to the line, and now we need to get to any point on this straight line. Let's call it green. And to do that, we need just to have a vector which is on the line. It doesn't matter how big that vector is. We could say just tiny section here. It doesn't matter where it is on the line. It just needs to be going in that same direction. So that if we do get to the line, let's say we started at this blue, we could use the vector that's on the line, the direction, and travel up any multiple of that green line that we wish to get to any given point that we might need to get to. So we'll call that line, that vector that's on the line, B, and we will use any multiple of it. We'll call it T. T is, I don't know, 10, 15. If you want to get to this point over here, the T is probably 2, isn't it? That's about, well, okay, maybe 2.2. It's 2.2 lots of that green vector. So the T just is the multiple. And this is y equals mx plus c in vector form. This would be, what should we call it? Cartesian form, like for the coordinates. So further maths, you're going to do some beautiful stuff and extend that to 3 dimensions. Yes, so you're going to look at planes as well. Think of them as sheets of paper in 3D space, and then you've got a nice position vector to get to the plane, and then you've got a vector which is perpendicular to the plane, and then you can define the plane in a few different ways. But it's the start of big things in mathematics, people. A lot of exciting things to look for. I have totally exhausted myself, and I have done 2 hours. I thought I would do less. So time for me to scat, unless you have any questions, which I have a feeling you don't. I have a feeling they're going to come in at a different time. Don't forget to follow Patreon, and if you haven't already, subscribe to the YouTube channel. There's a couple of things that would really help the channel out and encourage me to keep putting stuff out there. It takes a lot of hours. I love doing it, but it's very difficult. So the support is much appreciated. And if you want to enter that competition, just make sure you do those two things and tag 2 other people who might be interested in this. I don't need people who are not interested in studying A-level maths, but if they might find this somewhat interesting to listen through on ×2 speed, please do so. You will be entered into the competition, and I will give you a free set of exam questions for your trouble. Thanks everyone for coming, and I will be on here for another 3 minutes, just because I know there's a delay and people might have questions coming out of the woodworks a little bit later. Bless you all. No more questions by the looks of it. I think that probably would have been enough time. So please follow the community. If you've got any more questions, you know where to put them. And see you around. Best of luck.